Hey developers, ever wish scrolling your web page could feel like directing a movie? Like you're the camera operator, smoothly guiding a full 3D scene? That's exactly what we're diving into today. I'm a UI developer, and I've wrestled with this in real projects. So I'm not just showing you flashy demos. I'm sharing the exact technique I use to combine Three.js with GSAP scroll trigger. We'll make your scroll drive a 3D world like a total pro. In this crucial lighting section, we're transforming our 3D scene from flat to cinematic using professional lighting techniques and atmospheric effects. When this video hits 200 plus likes, I'll pin the full source code in the comments. Your support helps create more deep dive content. Let's craft our professional lighting setup line by line. We start by declaring two lighting variables, Hemi and Key, both initialized as null. These will store our ambient fill light and primary directional light. Inside the add lighting function, we first enable the renderer's shadow system by setting renderer.shadowmap.enabled to true. This activates shadow calculations now that we have both shadow casters, our model, and receivers, our floor. We then set renderer.shadowmap.type to 3PCF soft shadow map. This specific algorithm creates soft, realistic shadow edges rather than jagged, pixelated ones. For our ambient lighting foundation, we create a HemisphereLight with three key properties. The sky color is pure white, the ground color is a soft blue-gray similar to light concrete, and intensity at 1. This mimics natural outdoor lighting, bright sky illumination from above, and subtle ground reflections from below. Adding this to the scene creates gentle overall visibility without harsh contrasts. Now for our star player, the directional key light. We initialize it with pure white color and intensity at 1.1, slightly brighter than ambient. Positioning it at coordinates 363 places it high and to the right, creating that classic studio lighting angle photographers use. Crucially, we enable shadows with key.cast shadow equals true. To optimize shadow quality, we configure the shadow map size to 1024 by 1024 pixels, the perfect balance between crisp detail and performance. We then define the shadow camera's coverage area, left at -8, right at 8, top at 8, bottom at -8. Creates a 16-unit square where shadows will appear. The near clip at 0.5 and far clip at 30 ensure shadows render efficiently only where needed. This directional light adds dimension and depth to our model. Finally, we create atmospheric depth with two techniques. First, scene.background sets our canvas to a very light sky blue, matching our floor color for seamless integration. Second, we add 3.fog using the same light sky blue, starting at 90% of our camera distance and fully fading at 300% distance. This creates subtle depth grading where distant model parts gently blend into the background, essential for realistic spatial perception. And that's how professional lighting transforms a 3D scene. We've combined soft ambient fill, dramatic directional shadows, and atmospheric depth to make your model feel physically present. In our next video, we'll connect everything to scroll using GSAP scroll trigger. You'll create camera moves and rotations that respond to every pixel scrolled. If this lighting setup brought your scene to life, please smash that like button. When we hit 200 plus likes, I'll share the full source code. Subscribe and hit the bell so you don't miss the scroll animation tutorial, where we'll make your scene feel like an interactive film. Got questions about light positioning or fog settings? Drop them below, I answer every comment. Press like so more developers find it. Subscribe to the channel for more CSS tips. See you in the next video.